Up till now, whenever we worked with data, we have worked with single values. We have worked with integers, we have worked with strings, we have worked with a lot of other data types. But every time we have dealt with only one value usually. So most of what we dealt with up till now has been variables that have one single value stored in them. However, when you're creating different programs, especially big ones, you don't necessarily deal with only variables that have one value stored in them. Usually what we have is a lot of data that we want to bundle together, and we want to manipulate them, store them, move them around, and use them in our programs. So instead of just one value, if we are talking only about integers, let's say we have many different integers that we want to group together. So this will be a collection for us. This is a collection of data. Now there are many different questions. What can we do with this collection? That would depend on how we structure this collection. But there would be some basic things that we need to be able to do with any collection of data, right? For example, we definitely want to have the ability to add something new to the collection. We also want to have the ability to remove something from the collection. We definitely want to have the ability to traverse the collection, which means moving from one element to the other. And there are many other things that we would want to do with our collection. So we need to have these abilities and many more other abilities based on what we require. There is also a question of how we structure this data. How do we keep them together? There can be many different ways. For example, you already saw arrays where we have elements that reside next to each other. We can have other structures as well. For example, we can also have linked lists where each node has a value stored in it and the address of the next node, and then the next node has the next value stored in it and the address of the next node, and so on. We can have a stack where each element is stacked on top of each other and you can only access the topmost one. We can also have a different structure known as a map. What happens in a map is that every element is assigned a key value. So for example here, 9 has the key value 4, 3 has the key value 1. So you access these elements based on their key value. So if you call key 2, 0 would be your result. If you call key 3, then 8 would be returned. There is no specific ordering of elements in the map. So this is an unordered structure. But if you look at arrays or lists or stacks, they're all ordered structures because they maintain the order in which the elements were inserted into those structures. So these are 4 examples of different ways in which we can structure our data, in which we can store our data. There can be many other structures, and in Java you will encounter structures named vectors, sets, queues, and a few more. They're all structures that allow us to store our collection in different ways. And each of these structures have different uses. So based on how you want to use your data, you would choose one of the structures to work with. All of them have different advantages and different disadvantages. So it really depends on what you want to do. And based on your need, you will choose any one of these structures to work with. And as I said, these are not the only structures. There are a few more, and we will look at them in later videos. But all of these structures will have some way of adding a new element, some way of removing an element, some way of traversing between the different elements, some way of processing these elements, and you will find out that there are many methods associated with each of these structures. So keep in mind that a collection is a group of objects. Here in this example, we looked at integers. Integers are primitive types, they're not objects. But when we use these structures, these collections, usually they convert each and every element into an object. So a collection is essentially a group of objects. It can be any kind of object. It can be animal objects, it can be car objects, it can be integer objects or string objects. The main point is collections are always dealing with groups of objects. And each object in a collection is called an element. So in this case, this is an element for the stack. This is another element for the stack. Here, this is an element in the linked list. So when we work with collections of objects, we use Java's collections framework. This framework provides us with a set of tools using which we can work with collections of objects in many different ways. And linked lists, stacks, maps, vectors, sets, queues, all of these things are part of the collections framework. Understanding the collections framework is extremely important if you want to program in Java, because you will be working with groups of data all the time. And in order to do that, a good understanding of the collections framework is extremely important. We will now start to look at what this framework looks like, and we will individually look into the different pieces of the collections framework. The intention of this video was to introduce you to the concept of working with groups of objects together. We will take a deeper look into most of these structures that I mentioned here, in addition to a few more that were not mentioned in this video. So let's move on to understanding the collections framework.